Ladies and gentlemen, welcome. You normally hear about several types of electric vehicles. There are hybrids, plug-in hybrids, battery electric vehicles, and many others. In this section, we will talk about the types of electric vehicles and we will learn how to identify an electric vehicle type. Vehicles can be classified based on drivetrain and fuel type, such as conventional internal combustion engine vehicle, the alternative fuel internal combustion engine vehicle, and the electric vehicle. The internal combustion engine is commonly referred by its short name ICE. The conventional internal combustion engine vehicle includes the gasoline and diesel vehicles. The alternative fuel internal combustion engine vehicle refers to vehicles that run on a fuel other than a gasoline or diesel, like autogas, natural gas, biofuel, or hydrogen. In all forms of internal combustion engine vehicles, the drivetrain is mechanical. In contrast, electric vehicles use an electric drivetrain for the propulsion. In this lecture, we will focus on electric vehicles. While battery electric vehicles have an electrified drivetrain, they can be classified based on their energy sources, their propulsion devices, and how their propulsion devices are hybridized. In general, we have hybrid electric vehicle, plug-in hybrid electric vehicle, battery electric vehicle, fuel cell electric vehicle, and in the future, solar electric vehicle. The hybrid electric vehicle sources its energy solely from gasoline or diesel, while it uses both the electric motor in combination with the battery and a combustion engine for propulsion. The plug-in hybrid electric vehicle is similar to the hybrid electric vehicle that it uses both an engine and an electric motor for propulsion. The difference is that the battery of a plug-in hybrid electric vehicle can be charged by electricity via a charging port. In contrast, the battery electric vehicle does not have an engine and is purely powered by electricity instead of fossil fuels. Further, the propulsion is solely driven by an electric motor. Finally, in the case of a fuel cell and solar electric vehicle, the energy is directly sourced from hydrogen using a fuel cell or from solar panels respectively, while the propulsion is done using an electric motor. Now let's look at these vehicles one by one. For reference, let us start with the gasoline and diesel vehicles that uses an internal combustion engine for propulsion. A gasoline car typically uses a spark-ignited engine rather than a compression-ignited systems used in diesel vehicles. The engine uses a complex mechanical transmission system to transfer power to the wheels. Similar to a gasoline vehicle, hybrid electric vehicles are powered by an internal combustion engine as well. However, in addition, an electric motor can propel the vehicle by using energy stored in the batteries. The battery is in turn charged by drawing energy from the engine by using the electric motor as an electric generator. To operate the motor and generator mode, a clever power electronic motor drive is used. The extra power provided by the electric motor allows for a smaller engine. Further, the motor allows the engine to be operated in its optimal efficiency point, resulting in a better fuel economy. What we have just seen is a parallel hybrid architecture where both the engine and the motor can power the wheels at the same time. A series hybrid electric vehicle, on the other hand, works differently. The internal combustion engine is used to drive a generator and provide electrical power for the traction motors and to charge the battery. This is a common propulsion method which has been used in locomotives for many years. The traction motor is the only power supply unit with a direct connection to the wheels. The advantage is that the internal combustion engine can be operated at its most efficient point to generate the necessary current for drawing the traction motor or charging the battery. The third type of hybrid is the series parallel or dual mode hybrid. This has the flexibility to operate in either series or parallel mode by using a power split. It has a generator to charge the battery, as seen in the series hybrid, and it has also an engine and motor simultaneously powering the wheels, as seen in the parallel hybrid. Although this type of architecture is more flexible in terms of driving modes, it is also more complex and, of course, costly. The Toyota Prius is an example of a hybrid electric vehicle based on the series parallel architecture. Plug-in hybrid electric vehicles are similar to hybrid electric vehicles in that they have both an engine and motor for propulsion. The main difference lies in the fact that plug-in hybrid electric vehicle batteries are larger and can be externally charged using the onboard charger. This is beside the fact that the battery can be charged using the internal combustion engine while driving. This enables the plug-in hybrid electric vehicles to use the electric motor during larger periods of time when driving. That means for larger distances. It means that a plug-in hybrid electric vehicle can drive electric for most city commutes and switch to fossil fuels for long highway rides, removing any range anxiety. What is shown here is a plug-in hybrid electric vehicle based on parallel drivetrain architecture. Similar to what has been seen before, a plug-in hybrid electric vehicle can be built based on a series and series parallel architectures as well. The Chevrolet Volt is an example of a plug-in hybrid electric vehicle based on a series parallel architecture. The disadvantage of the hybrid electric vehicle and plug-in hybrid electric vehicle is that they continue to use fossil fuels and hence have tailpipe emissions. To overcome this, the battery electric vehicles or all electric vehicles have an only electric motor and no internal combustion engine. The vehicle uses a large traction battery pack to power the electric motor, and the battery must be charged from a power outlet where it is parked. The Tesla Model S is an example of a battery electric vehicle. Next, we look at a fuel cell electric vehicle. A fuel cell electric vehicle substitutes the larger battery of a battery electric vehicle for a fuel cell stack to generate electricity from the hydrogen fuel. Unlike a battery, a fuel cell is not a storage device, but a component that produces direct current from a chemical reaction. A small battery is still used as an energy buffer and to power the electric motor using the motor drive. A fuel cell vehicle has the advantage of short refueling times and extended driving range when compared with battery electric vehicle. Here are two examples of fuel cell electric vehicle, the Hyundai Tucson and the Toyota Mirai. Now that we know that all electric vehicle types, let us compare them based on a factor called hybridization rate. The hybridization rate is a measure used to describe how strongly the powertrain is hybridized. This level is determined by the role that the electric motor has in the performance of the car. It is defined as a ratio of electric power to total power and is described by the equation where PEM is the power provided by the electric machine and PICE is the power provided by the internal combustion engine. The classification for different values of hybridization rate is shown in this bar chart, including typical values of the power rating of the electric motor. On both sides of this bar, we can see the internal combustion vehicle hybridization rate is 0 and the battery electric vehicle hybridization rate is 1. When the hybridization rate value is smaller than 0.24, this hybrid electric vehicle is considered to be a microhybrid. When the hybridization rate is between 0.24 and 0.38, it is then distinguished as the semi or mild hybrid. When the hybridization rate is higher than 0.38, we can then consider it as a full hybrid. Apart from that, as we introduced before, if the battery of a hybrid electric vehicle can be charged from a charging port, it is classified as a plug-in hybrid electric vehicle. So, to wrap up, this table shows the overview of all types of electric vehicles. In case of internal combustion engine vehicles, they are solely powered by the internal combustion engine and has the most emissions. Hybrid electric vehicles and plug-in hybrid electric vehicles are powered by both an internal combustion engine and an electric motor that uses energy stored in the battery. The battery is charged by the internal combustion engine for both. For a plug-in hybrid electric vehicle, the vehicle can be plugged in an electric power source to charge the battery. Battery electric vehicles use no fossil fuels and have zero tailpipe emissions. Like a plug-in hybrid electric vehicle, the electric vehicle batteries are charged by plugging the vehicle into an electric power source. Finally, a fuel cell electric vehicle uses fuel cell powered by the hydrogen and battery to power vehicle using an electric drivetrain.